In this video we're going to complete example 2 and we're going to solve a pair of simultaneous equations using what is known as the elimination method. Once we've solved them, we're also going to use desmos to check if our solution is correct. So we'll start on question A. You will notice when we look at our two equations that the x's are lined up, the y's are lined up, the equal signs are lined up, and the numbers are lined up. And this is really important for when you're using the elimination method. We're actually going to subtract these equations, similar to the way we did it in primary school. You might remember when you subtract two numbers, you would put a line across like this and you would put the subtraction symbol there. And that's basically what we're going to do for our equations. We're going to go 2x minus x. Well, what's 2x minus x? Well, it's x. And then we're going to go, what is y minus y? Well, y minus y is 0, which basically means that the y's are going to cancel out. The equal sign stays there. And then we go, what's 5 minus 3? And this comes out to 2. And this has worked really well. We've already found x. X equals 2. Now what we need to do is find y. And that's not too difficult because we just pick either equation. I'm going to pick the more simple one down the bottom, x plus y equals 3. So if x plus y equals 3, and we know that x is 2 up here, which we can substitute in place of x, then we get 2 plus y equals 3. And we can see just by looking that y has to equal 1. This is really simple because 2 plus 1 equals 3, so y must be 1. We've now found our two values. We've found x is 2, and y is 1. Let's now check it on desmos. Alright, so our equations are 2x plus y equals 5, 2x plus y equals 5, and the other equation was x plus y equals 3. X plus y equals 3, and the point of intersection is 2, 1, or where x is 2 and y is 1, which is what we had, x equals 2, y equals 1. Let's actually write our point of intersection down. So point of intersection is or equals 2, 1. Now I would like to point out that for this question we gave the point of intersection, but we didn't have to. And the reason we didn't have to is the question did not ask for the point of intersection. It just asked us to solve the pair of simultaneous equations, meaning that it's quite appropriate just to write that x equals 2 and y equals 1 and stop there. Make sure you always read the question because sometimes the questions will specifically say give the point of intersection, and that means that you have to give it as a point. Let's now move on to question B. We can see that the y's line up, the x's line up, the equal signs line up, and the numbers line up, which tells us that we can use the elimination method. The question we have to ask ourselves is this: are we going to add them or are we going to subtract them? In question A, I just told you that we were going to subtract them, but you're not always going to know what you need to do. So we look at it and go, all right, we know the y's line up, but this is 4y and this is y. And when we look at the x's, they line up also. But the interesting thing is that the x's have the same number in front of them. They both have a 3. And this is where we're going to focus. We're going to focus on the pronumeral that has the same coefficient or the same number in front of it. You will notice that one of the 3's have a minus sign in front of it, and one of the 3's have a plus sign in front of it. When we did question A, they both had the plus sign. They were both the same. And in that situation, you always subtract. But when the signs are different, like in question B, we actually add them together. All right, let's go through it. What's 4y plus y? That gives us 5y. And then what's negative 3x plus positive 3x? And because they're opposites, they're actually going to cancel each other out. They make 0. And then finally, what's 7 plus 3? Well, that's 10. And we've got to copy the equal sign down as well. So we get 5y equals 10. It's not solved yet, but this is a really easy equation to solve because all we need to do is divide both sides by 5. And what do we get? Well, 10 divided 5 is 2, so y equals 2. Now we need to do is find x, and the way to do that is to pick either equation. I always like to pick the easier one. Y plus 3x equals 3, I reckon, is the easier one. Y plus 3x equals 3. Now, I know what y is. Y equals 2, so I'm going to substitute that in place of y. That gives me 2 plus 3x equals 3. So I'm going to have to solve this, and I need some room, so I'm going to move it up here to the right. The first thing I want to do is I want to subtract 2 on both sides, because this will cancel out the 2 on the left, giving me 3x equals 1. And now I can divide both sides by 3. This gives me x equals 1 over 3, or 1/3. And it's quite appropriate just to leave it like that, just as a fraction. In fact, I prefer it as a fraction. So we found y is 2, and x is 1/3. Let's write it down as the point of intersection, even though we don't have to. We'll do it anyway. Point of intersection is x is 1/3 and y is 2. So we're going to check this on desmos. So we've got the equation 4y minus 3x equals 7. 4y minus 3x equals 7 is the first equation. And the next one was y plus 3x equals 3. Okay, and where do they intersect? They intersect at the point 0.333 for x, which is 1/3, and a y value of 2, which is exactly what we had, which is great. All right, we've got 2 more examples that we're going to go through, questions C and D. So let's look at question C. The x's line up, the y's line up, the equal sign and the numbers line up, which is great. But we're faced with a bit of an issue. And the issue we're facing is that neither the x's nor the y's have the same coefficient. The x's have a coefficient of 2 and 4. The y's have a coefficient of 3 and 2. So we need to manipulate one of these equations so that either the x's or the y's have the same coefficient. To do this, I'm going to multiply the first equation by 2. You're allowed to multiply an equation by any number. You're even allowed to divide an equation by any number, as long as you multiply every term by the same number. So for equation 1, I've got to multiply all 3 terms by 2. And to save confusion, I'm actually going to label each equation with a number. This is equation 1, and this is equation 2. This way you know what equation I'm talking about. So we just said that we're going to take equation 1 and multiply it by 2. What's that going to give us? What's 2x times 2? Well, that's 4x. And what's 3y times 2? Well, that's going to give us 6y. We need to put the minus in first. And then what's 2 times 2? Well, that's 4. Now we've got a new equation. So let's label this one as equation 3. So we now have 3 different equations. What I'm going to do is I'm going to write equation 2 below this. Equation 2 is 4x plus 2y equals 20. And I'm going to remind myself that this is just equation 2. Now the good thing is we can subtract these two equations, and the reason we can do that is because the x's have the same coefficient. The coefficient is 4 and they're both positive, meaning we need to subtract them. When we subtract them, the 4x from both equations will cancel, and then what's negative 6y minus positive 2y? Now when you subtract a positive number, it's the same as just subtracting. So we're going negative 6y minus 2y. And negative 6 minus 2 is actually negative 8. And if you're not very good with negatives, just use your calculator. Just go negative 6 minus 2. It will give you negative 8. Alright, so this is going to equal, and we need to go 4 minus 20. Once again, if you're not good with negatives, just use your calculator. 4 minus 20 is negative 16. I can see looking at this, it would have been a lot easier if I had put equation 2 above equation 3. Anyway, that's fine. It still comes out with the same answer. I'm going to divide both sides by negative 8. And the reason I'm doing that is the 8's will cancel and also the negatives will cancel. This leaves me with y. Negative 16 divided negative 8 is actually positive 2. So we've found y, and now we need to find x. Once again, we just need to pick either equation. I'm thinking the second equation is probably easier. So we have 4x plus 2y equals 20. Remembering that y equals 2, so we can substitute this in place of y in the equation. When we work that out, we go, alright, if y is 2, this is going to become 2 times 2. This is going to become 4. So I'm just going to write that as 4. So 4x plus 4 equals 20. Now I'm going to subtract 4 on both sides and cancel out my 4 on the left. So 4x must equal 16. And then I'm going to divide by 4 on both sides. X will come out as 4. So my point of intersection is going to be an x value of 4 and a y value of 2. So I need to check this on desmos. My first equation being 2x minus 3y equals 2. 2x minus 3y equals 2. And the other one, equation 2, 4x plus 2y equals 20. And the point of intersection is an x value of 4 and a y value of 2. So I know that I've done that one correct. We're now going to move on to question D. Obviously, I'm going to have to rubble this out to make some room. This time, things do not line up. The y lines up with the x, which is not what we want, and the x lines up with the y. To fix this, we're going to have to do some rearranging. And I think it'll help if we label the equations again so we know which one we're talking about. This is equation 1 at the top and equation 2 at the bottom. I'm thinking I should keep equation 2 the same and rearrange equation 1. So I'm going to copy equation 1 down below. 2y equals 5x minus 19. And I'm going to remind myself that this is just the same as equation 1. Alright, I'm going to subtract the 5x on both sides. I'm going to do this because I want my x to be on the left side, just like it is in equation 2. I can now cancel out the 5x on the right, leaving me with 2y minus 5x equals negative 19. Now it's a lot better now because equation 1 has 2y and 5x on the left side. which is similar to equation 2, which has the x's and the y's on the left side as well. The problem being it's not exactly in the right order, because equation 2 has x then y, our one has y then x. That's really not too difficult to fix though, because all we need to do is swap them around. The negative 5x goes on the left, and it's positive 2y on the right. Really important when you swap them around to think about where the negatives and the positives go. This negative or minus sign belongs to the 5x, so it needs to come with it to the left side. And this 2y technically has a positive there, so it needs to become plus 2y. This will equal negative 19. Now I want to point out that this is still equation 1. I can still say, well, technically this is equation 1. It's just been rearranged. I haven't remade the equation. I haven't multiplied it or divided it by anything. So we'll just keep it as equation 1. Equation 2 we'll write below it, which is 3x plus 7y equals negative 5. And I'll just write that this is equation 2, so I know where it came from. And I need to either add or subtract, and once again the coefficients are all different. We've got 5 and 3 in front of the x's, we've got 2 and 7 in front of the y's, so this is not going to work very well yet. I'm also realizing I really should have written this all on the left side. I have the luxury of being able to move this all over. So what am I going to do? Well, I think I'm going to make the x's the same. I'm going to focus on that. And the way I'm going to do it is I want to multiply my 5 by 3, because that'll make 15. And I'm going to multiply my 3 by 5, because that will make 15. I've got to make them both 15. I'll start by taking equation 1 and multiplying it by 3. This is equation 1 here. So what's 5x times 3? That's 15x, or sorry, negative 15x. Remembering I need to do it to every single term, so I also need to multiply 2y by 3. That'll become 6y. And then finally, negative 19 times 3, which is negative 57. Now I'm going to take equation 2 and I'm going to multiply this one by 5. I have to do it to every single term in equation 2. 3x times 5 is 15x, which is great. This is what I'm looking for. I want the coefficient of x to be the same for both equations. Let's now look at the y now. 7y times 5 is 35y, so plus 35y. And then finally negative 5 times 5, which is negative 25. Great, I have two equations which have a pronumeral that shares the same coefficient. And I'm going to add them together because we've got a negative 15x and a positive 15x. If the signs are different, you add them. This means that the x's are going to cancel, which is great. That's what we want. Next, what's 6y plus 35y? Well, that's going to be 41y. And then what happens if we add these together? Negative 57 and negative 25, if we add them up, it's going to make a negative number of negative 82. And if you're not good with negatives, just work it out on your calculator. Just go negative 57 minus 25. All right, now we need to divide both sides by 41 to cancel out the 41. Y will come out to negative 2. Really nice. All right, now we need to do is find x. We pick either equation. I think that I will pick equation 2. I just need to give myself some room to do this. All right, that's going to help. So equation 2 says that 3x plus 7y equals negative 5. And we know what y is. Y is negative 2, so we're going to substitute that here, giving us 3x plus 7 times negative 2, or 7 lots of negative 2 must equal negative 5, which means that 3x minus 14 equals negative 5. Let's now solve that one. I'm just going to move it up here. We're going to start by adding 14 to both sides. This will cancel out the negative 14 on the left, giving us 3x equals, and negative 5 plus 14 is 9. Now we can divide both sides by 3. X will come out as 3. Alright, so our point of intersection, and I shouldn't have put that dot there, our point of intersection is going to be an x value of 3, and our y value was negative 2. So it's a real nice point here, 3 comma negative 2. And we're going to check this on desmos. Let's bring it up. It's going to be hard for me to remember these. So we've got 2y equals 5x minus 19. 2y equals 5x minus 19. And the other equation is 3x plus 7y equals negative 5. 3x minus 7y, my memory is terrible, plus 7y, sorry, equals negative 5. Excellent. And we get the point with an x value of 3 and a y value of negative 2. Anyway, that concludes our video on example 2. Remember to read the description below for links to workbooklets that relate to this video.